Cool. I think Elaine might ask you a couple questions, but I might meet with her tomorrow if she has time to talk with her about the steps that she should take in order to get to like what you expect from,
Yeah.
right? Because
Actually, I just met with Gamzi Gasoi, the new faculty member. We're trying to actually she hasn't officially accepted our offer yet, but she's the person that gave me this inspiration. It originally inspired me to do this privacy research.
really,
Yeah,
okay,
she did a lot of privacy research, but based on looking at transcriptome data and then identify basically identity associated SNPs, like genetic variations.
does the format VCF function is the input, that's a sig set, right? Okay, yeah, it is.
Uh,
Just making sure I understand.
Actually, based on today's discussion, she's very interested in like helping us kind of do that, write that paper, basically.
Yeah,
But
she could probably get in contact with Elaine too.
yeah.
So John, while we wait for a kill, where are you guys at this point?
Well, I think from what we were saying yesterday, so our confusion was we were initially under the assumption that we were going to do this in Linux. So we set up a program to do what we needed. And then while we were talking, Akil asked you, I think.
Yeah.
And you were like, no, you guys are in the wrong area.
Yeah, we wrote a whole code. We based it off that code we made that day for the bed files that Ethan helped us write. And we recreated the whole kind of code. And then we Googled, how to do RDS files with like Linux. Nothing came up. So we were like, okay, this is
for our data structure.
Yeah, we learned the hard way.
I think so. So the idea is what the data structure should look like. The data structure is a list of vectors of probe IDs, right? So for instance, you could use, for transcription factors, you could use the GSMs as labels, and in each GSM, that's the label, would just be a vector of probe IDs. So I think I used the example for a kill yesterday when I was texting with him, that if you were looking at like one transcription factor, we use MYC, we use MIC as an example plenty of times because there's like 18 of them, 18 different samples for MIC. One of the samples of MIC, I'll type it in the chat. Actually, I'll share whiteboard. So like what it might look like is a list where you have some GSM equals a CG XXX. That'd be the first one, CG XXX. And then you'd continue for all of the
GSMs.
I don't know if you want to. Would you want to? Okay, this is a question for Wanding. Would we want to have would we want to save this RDS? Would we want to save this list? Would this list be on a per transcription factor basis? For instance, would you have for MIC one RDS file corresponding to all of the quote unquote replicates, but for, you know what I mean? Or
I think it all depends on how big the data structure becomes. If the data structure can hold all transcription factors in as like without making the saved file too big, I think I'll just prefer putting them all in one list. But I also worry that if the list becomes too big, then it becomes unwieldy to kind of load the whole thing. If we all we interested in is just a few like transcription factors.
Yeah. So, John, my question from Wanding was, do we want to have all the GSMs in one list, or do we want to separate the lists based on which transcription factor they're from? So you would have like one list for MIC, one list for, I don't know, another transcription factor, and then so on. I guess like transcription factor is 0, one list for factor 2, something like that.
Yeah, another option would be just to store one file for each GSM. So that way we don't have to have a list, and it will simply be a character vector, right?
Yeah, so now we're talking about 3 different options.
Yeah.
Okay, so I'll illustrate that. You basically
but the problem is we then need to kind of read multiple RDS files every time we want to kind of do our test.
So what would be interesting is if they could do these 3 representations and then figure out which one would be, I don't know, the best based on the data we have, focusing on transcription factors first. Do you guys have questions? I mean, really what you do is you pull the data in, like you have the bed files, right? You could, or maybe they're TBK files now. You pull the TBK files in, you'd read which, for each GSM, you'd read the probes that have values or not NA or have a true value or whatever, however you store the data, and you construct these factors, you construct these vectors, and then you could store it in one list. You could segregate it per transcription factor, or you could have, you could just store them all separately.
Yeah, I think the first thing we want to see is how big is each GSM. Like if we start everything into like one RDS.
Like this.
Yeah, I think everything into one RDS is actually nicer because you then can just share that one RDS as all the database sets with another person without copying, paste, and compress into a file.
Yeah. So Akhil, how would do you two have any questions?
Not immediately. That was the first option where your cursor is hovering over right now is what we were trying to get at with trying to, would this essentially be a list of lists of GSMs with the vector of CGs like attached to it?
Yeah, it's a list of vectors.
Okay.
Yeah,
that's what we were initially looking at. I guess I think we just, as we mentioned before, we're going about it in the wrong workspace.
Yeah. This is like another GSM, GSM2, and you have CGXXX, CGXXX, and this might continue for a while.
Yeah,
but it's just for all of them. Cool. Yeah, so if that's just the confusion, I'm pretty sure all the transcription factors, I'm going to open up that file real quick, because I'm pretty sure that all those transcription factors are saved as TBK files in the annotations folder.
Yeah, I think that's how we initially did it for converting them for the binary. When we converted them into the bed files, that's where we took them from, was annotations.
So what you can do is you can just load in, you can just read those, you can use Tbmate to read in those TBK files, and then you can just create that structure using the data. And if you don't have Tbmate installed on HPC, what you do is you just go to your home directory and you can do, you can clone the Tbmate repository, and then I think you have to put it in your path variable. And if you don't know how to do that, you can just Google it.
Yeah.
Okay. Cool.
Yeah, I think I've already shown you how to use Tbmate last time when you create a Tbmate pack, right? So I've asked you to create that Tbmate file. So you must have already used that software somewhere.
Yeah, I think we already have.
Yeah.
Did they pack it in R or do they pack it in?
I think it's a packet on command line.
Okay, because yeah, when you use it in R, you have to like source to your tbmate.r file.
Yeah.
But I can talk to you guys about that when you get there. Do you guys want to like try it right now? So if you have any questions, you can like let me know.
Yeah, I think that would be a good idea. Like, will be an effective way for you to.
Either whoever wants to take the wheel.
Yeah.
I would, but I actually have to run to the bathroom real quick, so I will be
Okay.
back in 1 second.
So a kill.
All right. Am I just using R console?
Yeah,
I
I mean,
missed
you can
them.
just you just go on to HPC. Are you connected right now?
No, not yet.
Okay, so then you can connect.
just- Yeah.
Oh, Wanding, is there a way for me to connect Dropbox to my HPC? I was kind of thinking that that's what you do.
No, there's no easy
Okay.
way to access Dropbox. Actually, I've thought about this a while ago.
Yeah,
I
I figured
know
what I'm
there
doing.
is some API, but it's too complicated to set up.
I'm just R syncing back and forth using like SCP.
Yeah, that's not very handy, but
No.
unfortunately, there's no way. Yeah.
It's reloading. And he's gone. It's because of the VPN. All right, John. He's just reloading. He's connecting.
Oh, I was gonna say we lost a man.
Yeah.
Give me 1 quick second. Let me go into that.
Yeah, I think I'll probably just go like write my like master rate paper.
Yeah. No worries. I'll help him out.
I'll let you figure that out. But I think it should be pretty straightforward.
Yeah.
All right. Well, thanks, Ethan, and have a good night.
Have a nice night.
Have a nice night.
All right, guys.
All right, cool.
Let's figure this out. Okay, so do you have Tbmate installed?
Yeah, this already has Tbmate.
Can you type Tbmate? Okay. Can you do which Tbmate? Which space Tbmate?
Like which?
Yeah.
Like the evil.
Okay, and can you CD to that folder? Okay, CD to lab bin. CD to that path, but not Tbmate. So just that path except for Tbmate. And do ls.
What'd you say?
The ls command.
Oh, sorry, I didn't hear you.
We have Python in here. That's cool.
I don't see a tbmate.r.
Yeah, that's not there.
Could you do tbmate.r and hit tab? Capital R. Yeah, no, it's not there. Where would it be? I'm gonna basically tbmate.r is something you load in whenever, I might just move it because I have it. I'm going to copy it to the lab bin. Could you paste that link in the chat for me?
Yeah, of course.
Thanks. All right. I wonder if this is going to work. Okay. CP this to, where's Zoom? Lab bin. Okay, can you do LS now?
Yes, there.
Okay, so we can just start here. Do R. Yeah, and then you're gonna want to source. You're gonna want to do this. You're gonna do source. I'm typing it.
Should I do it from this directory or should I leave the directory?
You have to type in R. Yeah, you can do it from this directory. It's fine.
Okay.
Just hit enter for R. You should copy and paste that.
Yep.
Yeah. Basically what you're doing is you're loading in R so you can enter. I wonder if this is gonna work. Oh, you have to replace the quotes.
Oh yeah, I see it.
Yeah, hit Control A to go to beginning of the line. Okay.
Well, I was already there. I was like,
yeah. Okay, cool. So now if you type read
is it read underscore D? It's read underscore DS, I think.
No, I'm thinking about how you read in TBK. Where would it be? Do TBK underscore and then hit tab.
Nothing.
Do Tbmate and then 2 colons and hit tab. Three colons, hit tab. Nothing.
Nothing.
Okay. So I need to see what's in that file, or at least I need to figure out what the R function is. Give me a second. I'm gonna Google. I'm gonna go to the scripts R. It should be do TBK underscore data and hit enter. There we go. That's the function. Okay. So effectively what we're doing is we have to read in the TBK files. Now, do we know where they're located? Yes, we do.
Yeah.
Annotations.
Yeah, but the thing with that is you need to know which. Okay, but they're the GSMs, but you'd only want the transcription factor ones. So what we're gonna need to do is, you know how we have that database
binary?
We have that database Excel spreadsheet, right?
Yeah, the MM285, the like 2021-032.
Yeah, so we need to open that.
I think that's also in annotations, I think, before.
The Dropbox? I mean
the
that
XLSX.
the Excel is in there?
No, I think it's also it's in the Dropbox.
Okay.
It's also I think it's in the annotations directory. Like around there.
Okay. What I'm gonna do is I'm gonna move this file. I'm gonna copy this file from Dropbox to you.
Okay.
Figure out where it is. Give me a second. A lot of moving files around. Show lab data, or no, it's in your CG, isn't it? Yeah.
Yeah.
Database sets. Okay. Copy as path name. All right. Just hang tight.
No problem.
Dot. SCP dash or two. Do you have a folder which you do work in for this?
We didn't make a directory yet.
Okay. Could you make a directory?
Yeah.
I'm gonna teach you how to use something. You can just exit out of this.
Yeah. How the hell do I exit?
Just hit Control Z or quit.
Oh, cool.
Okay, type screen. All right, then do fn2 like function f2.
Oh, function F2.
You have a Mac, right? It's like the
Yeah,
fn.
yeah.
Okay,
Yeah.
so now you have two windows. So you can toggle back and forth using fn and f11 and fn and f12.
Okay.
So just go to the first one.
F11 you said for that?
Yeah. You have to do fn and f11.
Oh, okay. FN.
No, you don't type it. You use the keys, right?
Oh,
You
yeah,
have-
no, I'm hitting phone. Yeah. It's not only thing is moving though. Oh,
Yeah,
it is.
it
Oh,
did,
it
okay.
is.
So, right, this one create a file in in the lab projects.
Yep. CD.
I think you might have a file there. Do ls. Yeah. You have binary. You have two binaries. Impressive.
Yeah, this is the one that crashed that day. That got halfway, and this is the new one we made.
Okay, so you can get rid of the one that doesn't work.
Yeah, I mean, when we were trying to make it work, me and John went into this old binary one when we tried running the other code with bed files and said, see how it worked out.
Okay, you can delete that one.
Okay, yeah, 2021-0513 underscore RDS file.
Sure. Make sure is one.
Word.
There we go.
Okay, cool.
And then do
Isn't it RM to remove?
yeah, rm-r, because you have to do a recursive elimination. You have to do a space between rm-r. And then just select the lowercase binary one.
Yeah. Yes.
Yes, I think it's yeah. Oh shit. Okay. Hit Control C. And then put an F next to R. Yeah. There you go.
So it does it for you.
Otherwise, it'd ask you for each file whether you're sure.
Oh, that'd be
Okay.
a pain.
Now go to that file you created, a new file, and then do echo $pwd, but pwd is capitalized. pwd.
Oh.
For path. Okay, then copy and paste that and send that to me.
Okay.
Ooh, wait a minute. Oh shit. Sorry, 1 second. I have to prepend it with. I'm using SCP. John has done this before.
Yeah.
Send it.
Send it. Okay, in your other tab, you can load R.
Why aren't you working? Okay, cool. See load R?
Yeah. in the other tab. It's in the other tab?
Yeah.
When I say load R, don't like type load R, just R, right? Okay, and then you're gonna source that file I sent you to get Tbmate to work.
Okay.
You have to replace the
Place the quotes again.
okay. Okay, and then you're gonna need another library. Forget which one it is. Oh, read Excel. So can you install the package read Excel? Read XL, like read Excel.
Do I just type package?
It's install dot packages read Excel in quotes.
Read.xl?
No, lowercase read XL, as in the letter X and L. Yeah, do that. And then I think it'll be 74. Yeah, it's 74.
Let's see.
Read Excel is going to allow you to do a function. Allow you to use this function that I use to read Excel files in.
Did we just download something from Ohio?
No, that's just the server.
Oh. Is that the closest one to us?
Yeah.
Yeah. That's kind of funny.
So I'll teach you the way to learn how to use this. So the one you selected is the one you currently curating is in Meta 80, right? That tab of the Excel file. Okay.
Yeah. Oh, I thought that was a rhetorical question. Yes, I think it's in Meta 80.
That's something random. Should be downloading.
Wow.
It's taking a while, huh?
Okay, cool.
Did it finish?
Yep.
So then you can just load it.
Is it this one, packages.html?
No. Packages.html is, I think, the metadata for it. What you need to do is you need to load read Excel.
Oh.
So how do you load a?
Is it? No.
No, it's not. It's use library, the function, read Excel. Not in quotes.
Oh, okay. And then that's it?
Yeah. Congratulations. Okay. And in random, I sent you code that's going to allow you to use a function provided by read Excel to read in the Excel file.
Okay, so where'd you send it?
Mm.
In the random in the Slack.
Oh, in the Slack. Hold on.
Because the quotes are messing things up. No, and don't copy and paste it yet. I totally messed something up.
Okay. You want me to change the quotes in this one? Or
Yeah. If you copy and paste it, should be fine.
okay, cool.
So what read Excel is doing is the first argument is the file path, and the second argument is the tab in the Excel file.
Okay.
So
Let me run it.
Work. And do warnings parentheses. That's fine. Do sample sheet to view the file.
That's it.
No, it's the variable name, not a function call.
Oh. Wait, so what do I do?
Sheet, sample sheet. You were there. You were there and hit
enter?
enter. Yeah, we're just viewing it.
Oh, okay.
Okay. And that's the data, right?
Yeah.
All right. So what we're going to need to do is we're going to need to select. So this is as a tibble. And I have not worked with tibbles. So we're going to learn this together. You guys need to, one quality skill to learn is, okay, before I get into like Googling what we need to do, we need to think about what we need from this data. Now, John, can you tell me what we need from this data? Why might I have helped you load in this file?
We need the GSM names.
For what?
The ones that are only TF though.
Yeah, we don't want any of the attack seek. This is what we ran into last time.
Yeah, so you want only the sorry, give me a second.
Wait, I have a question. Do you remember how last time we ran the program that isolated only the TF files?
Yeah.
Can we just pipe that to a new file then?
No, because you didn't save GSMs.
Oh, okay.
All right. So do you mind if I play around?
Yeah, you got it. I'll give you control. Yeah, go ahead. Oh yeah.
Click, please.
Yeah, I did.
There we go. Oh, that's not a function call, is it? So I guess we need to figure out, I wonder how do you view, okay, that's how you view it. So that's how you view all of the, everything in that first column.
Uh-huh.
So then all we need is we need to select the rows which say transcription factor, right? So is in the Excel spreadsheet, is it TF for transcription factor?
Mm-hmm.
If I remember correctly here, I'll open it up now.
TFBS. So what we need to do is we need to grab the rows, right? So whenever you do like subsetting in like any program, the first argument's rows, the second argument is the columns. So for this, we can just do the column will be file accession. And then so that the column we're grabbing is file accession. So if we do this, we'll get all the file sessions, right? We don't want all the file sessions. We only want the file sessions for which sample sheet.
$sign target.
Yeah. Oh, target group.
Yeah, target group equals TF.
Equals TF. Okay.
Did I mess something up? It's not auto-completing. And that's all of them, right?
Uh-huh.
With 2,707 more.
Yeah. So what we're gonna do is we're gonna say, here's what I do: GSMs equals this. So now we have all the GSMs.
Okay.
Okay. Now go to your other tab. I don't think I can do that. Can I? No, I don't think I can. Oh, I can. Shit. Now we're in full control. So this is your working directory here. Where am I? This is your working directory. Oh, I can only do F12. I can do F11. This is your working directory. This is something else. So what we're gonna do is we're gonna do this references. So John, actually, Akil, what might we need now?
You're gonna need the TBK files.
Yes, and where are they located?
Annotations and references. Oh, Infinium. and then mm285.
Beautiful.
Oh, and you're gonna run Tbmate view here.
Yes. But the trick is that we want to basically use this to only grab data from these files, right? So what we can do is we can do it. It's I think it's Tbmate data, tbk data, right? And the file, let's do path is equal to whatever we had in there, right? This is our path because all of them are located in there, and we have all these GSMs, right? And we basically need to look at what tbk data. Okay, head tbk data. Whenever you're in screen, you can't scroll up, which kind of sucks. But if you head, you can get it. So what we need to give it is the tbk file names. So what I'm proposing we do is we create a vector that has all of those GSMs appended to path like that. Okay. So what you can do GSMs $ file accession like that.
Did that just turn them all into strings?
Sorry?
Did that turn them all into strings?
They're already strings, right? But they're all strings, but it just doesn't show them as, you can see that it says character, and that just means it's a character array, which is a string. So what we can do is we can say for GSM in there, and we'll just do a for loop, and we'll just say must be an easier way to do this. Let's just print. Okay, so we can print the GSM, right? That'll give us all of it. And we want to only do that if the GSM is not NA. So if not is NA of GSM, print GSM. So now we only have the non-NA ones. And so what we want to do is we want to take path, and we want to basically attach each of them to the end of this, right? So you can go here, and in Python you might be able to do that in the print function, but in R you have to use paste. And what paste does is it concatenates strings. So you can do path GSM, right? And then in quotes you're gonna have .tbk, and then you need a separator, which is basically to say that it doesn't put space in between them. Normally you put spaces between them, and now you have all the tbk files, right? And so what we're gonna do, instead of printing them, is we're gonna append them to a list. So we can just do tbks. Oh, sorry, tbk equals list, it equals a vector. And we come in here, get rid of one of those. Get rid of, how do you do append? I think it's just, I think it's this. All I'm doing is I'm appending each one to the growing list of TBKs. So now we have all of them. Okay? And then the magic is when you do actually, let's go back to what TBK data expects. TBK data expects TBK file names, which we have. It says the index file name can be specified, but we don't necessarily need that. The reason we don't need that is because when you do like Tbmate header, tbk header of this file, you can print anything. That's silly. Okay, let's make sure that these files exist. It does exist, okay. So I don't know why that's not working, but it doesn't matter. But the function, what I'm saying is there's a function in Tbmate that will recognize that the index file is HM285, or sorry, MM285. So what we can do data equals tbk data, and we can give it whatever we named it, like tbks. And it's just loading in all of the packages because it's the first time we're using this function. Do you guys have any questions about what I did?
Not yet.
Okay. It was I try to ask you questions so you can follow it, and I didn't save any code to force you guys to understand it. Otherwise, because then you'll backtrack it. But you can always watch the video.
Yeah, of course.
Very true.
This will take a hot second. The idea then is to, okay, so then once we have all the data, what do you imagine we do with it?
Wouldn't you run a function that would basically weed out any TBK that doesn't line up with the TFBS ones we found?
Well, we already isolated TFBS.
Right? Okay, we did.
So what we'll have is data looks like this, right?
Well, hold on, let me delete this chat box real quick. Give me one. Okay, you got it. All right, you got it.
We want the CG names, right? We want the first column.
For which values?
We don't want negative values.
A 1.
So you want it for when it doesn't equal -1, right?
Yeah.
Okay. So then the data we're going to get in I send it equal to the variable data is you're just going to have a matrix where the rows are probes and the columns are samples. Could you describe to me how you like an algorithm to basically like, would you go through each column? Would you go through each row? The end goal, remember, the end goal is to have a list of vectors for each GSM, right? So where might you start to get that? Because like for this GSM I picked up, there's very few which don't have a -1. I can actually view all the non-1 values by doing grep dash actually okay, tbmate view dash d, right? Right, these are all the valued ones. Mm-hmm. So for this GSM, this one right here, you'd want that GSM label, that string label, associated with these probes.
Okay.
So what would be a way that you could subscripts out of bounds? That sucks. And I wish I could see the error because now it's gone. Okay, cool. It said subscripts out of bounds. Okay. Here's one idea. The first 10. Okay, so then you have data. And then if you do, I think dim data. Yeah, so what we have is we have 10 columns and then this many amount of rows.
Mm-hmm.
Okay, and you can do head of data. And you'll see that likewise, right? There are many NAs, very few values, but we want to isolate the probes for each GSM which has a value. So let's say that our data, let's just call it a database. Our database is some list. And what would be a method for adding like this to the database such that it contains probes that are not NA?
So would that would be column 2 technically, right? Because column
No,
1
it's
is
column 1.
That's column.
These are column names. So that's actually an important question. So this is something you can use. You can use row names. Sorry, we'll do head of row names of data. Those give you the row names, and then you can have head of call names of data.
Spell names wrong.
I understand. Me being fast and feel like I'm on a roll. Yeah. So no, this first NA under the first GSM would in fact be column 1.
So under each, so we're going to loop through the columns, and when we go through the columns, we're going to check if the value is
greater than -1.
Yeah, but that says NA.
Yeah, so there's only NA.
So if the value is NA, you won't just delete it.
Anything other than NA.
Yeah, anything other than NA.
Mm-hmm.
So is there any way we can leverage the fact that we have row names? Because the easiest case scenario we have is that one GSM has no NAs for all the columns, for all the rows, which it would imply that you just grab all of the row names.
Yeah.
So is there any way we could use the row names data? Let's break it up into an easier case. What could we do to grab the probes for the first column? Like if we don't think about looping, how could we grab the probes for the first column?
Would you just go into the file, find the ones that aren't NA, and just paste it?
We loaded the file in already, right? Let's grab the first column. Oh, sorry. I'm sorry. Did I spell head wrong? No, it's saying it's invalid operator. That's because of the fact that you can't use that for data frames, I guess. So what you can do instead is you can just query for it like this. That's also false. Like that. Okay. Oh, here's an even easier way. Okay, now I see an even easier way. So you see how for this we have all of the values and their row names.
Mm-hmm.
What we can do is we can do head na.omit and then this.
Oh, because it's giving us which ones are NA.
Did I spell something wrong? I'm pretty sure NA omit. Okay, and there you go. That's how you grab it. That's actually what I was gonna do is I was going to do a subset of row names, like I do row name, like similar to what we did for the Tibble, right? We did row names of data, and you subset it, and you basically say, I would do data. This GSM doesn't equal NA. And that just doesn't work. Okay. Wow, that is hilarious. I think it's because I have to do as vector. I love how I'm exploring this option, even though there's an easier option. Yeah, and I have no idea.
Interesting.
Because that should have worked, but in Pursuit, we found something easier. So the idea is that you'd have, like, let's say that we have like database, right, as an empty list, right? And we can do a loop over all columns. So you can do call names in call name in call names of data. Print call name. Wow, names is not giving it to me. We print all the call names, right? And then we effectively are asking, okay, can we do this? Can we print the head of NA omits? I'm just doing head for right now to illustrate a point.
Spell head wrong.
Jesus. And I'm too many
Too much coffee today?
I don't know what it was. It's nighttime, dude. I haven't had any.
True.
And then you replace this GM with call name.
Call name.
There, right? And then all you do is you get rid of the head. Actually, I want to keep. So we don't care about the values per se, right?
Yeah, we just want the CG names.
Yeah. So what you might do is you might just print the names of them, right? And then instead of printing them, you could say,
we want to paste them into the list.
yeah. So for that, you can do database. And then when you add something to the database and give it value, you have to use double brackets like this. I don't know why, but like that. And they're all saved there. You can view the names of the list by doing database, right? And I can do database like this one, this first one, and you see that it's these probes. And then you can just do save RDS of, I forget if it's file first.
No, it's name, then file, and then the final one you want.
So it's not this. I always do RDS lowercase, but I'm pretty sure that's just not right. Oh, well.
Save RDS.
Yeah. I wish I was better at typing. It saved me so much time.
I just watched some crazy video where this guy got up to like 200 words per minute or something like that. It was ridiculous watching this guy type.
But that's the idea. That's the process.
So did you just make the entire RDS file?
No,
Or
I did it for the first 10. Right, I had a
Well, when Wanding runs this, when Wanding uses this RDS file, does he not want the values, or he just wants the names?
He just wants the names.
Yeah, we just wanted a list of the names
Okay.
for each GSM.
So when I ran this command, it gave me an error because there's just some error. So I did it for the first 10.
Mm-hmm.
You can try it for like maybe you guys want to play around and see if this runs for the first 50, the first 100, the first 1,000, and then maybe you can pinpoint where the problem is. If you find a GSM that just doesn't exist, or I don't know.
That would be annoying.
Yeah. But that's the general concept. What I suggest you both do, if you are like uncomfortable, if you're like confused, or if you want to like reproduce this, is like go through the video after I submit it tomorrow, and try to reproduce it with a fresh start on R, which might take a little bit. It might take some time, but you can always skip through and backtrack because you know where I kind of went back.
Yeah.
Is that okay?
Yeah, that's fine.
Yeah, that's
Cool.
perfect.
Okay, cool.
Saturday's meeting, is it moved to 11 again or 1?
I guess it's whenever you guys want to have it.
Okay.
Oh yeah, I'm trying to go to the zoo on Saturday.
Ooh.
Okay, so then whenever we'll talk. We can talk in the morning and then figure it out later.
Yeah, of course. I mean, I'm good for any time.
Cool.
But trying to see some animals.
Yeah. You guys have any other questions?
Hmm?
You guys have any other questions?
No, this was very helpful, and I think just doing some trials on our own and then seeing what's up with the bounds. I think
effectively you want to load all of them in, and then you want to run that loop. Like you want to run the loop I ran. Like you can kind of see that I was just like playing around to show you how you'd progress to do it. But eventually you'd get to this for loop right here that would do it. So like this is the key.
Okay.
Yeah.
I would save this line of code and don't lose it, because that's what does it. So it's when Wanding said it's straightforward. It really is pretty straightforward. It's less than 15 lines of code, but it's figuring out the correct 15 lines of code.
Mm-hmm.
Okay.
Much appreciated, sir.
Yeah, thank you very much.
Yeah, you got it. And then after you do it for transcription factor binding sites, you can do it for chromatin accessibility, and you can do it for AttackSeek. You can do it for, you'll have this repertoire, you'll have this under your belt.
Does Wanding want to move on to different kinds beside TFBS, or just wants to focus on TFBS?
The idea is to have all. I think the idea is to have, like, let's just what I would aim for is to have one for all the transcription factor binding sites.
Okay.
By Saturday. Just, I don't know. I feel like that's
one big RDS file.
Yes. And then maybe see how big it is, right? What you can do, I saved it. Can I click? I saved it here. You can do disk usage, DU, and then database.rds. And you see that this one is 191 kilobytes. And there's 10 of them. Well,
I mean,
math.
Wouldn't it be easier for organization's sake to do it? Wouldn't it be easier to do an RDS file per category?
Per TFBS?
Yeah, one for one AttackSeek, one for TF.
Well, we are doing it. We're starting with transcription factor binding sites. So when we subset the Excel, we loaded the Excel file in, then we subset it for only those that are TFBS.
Okay.
And right now, what I want you guys to do is to use that. And then what we did is we just use those GSMs to create the file paths and store that in a list using a for loop.
Okay.
But like my point is, there's 191 kilobytes. So you just do 191 times 200 because you did 10 of them of the 2000, and you get that much. So it's about 38 megabytes.
That's pretty
That's not
low.
terrible.
I mean, yeah, that's reasonable.
It is reasonable. So that's what you should expect as a number. If you get something that's way higher than that, well, that's assuming that the probes are about the same. So you might get something very far off. But I'd say that in the magnitude of tens of megabytes is what you should expect.
Okay, cool.
It's like 30 to 50.
Yeah, somewhere around there. Because like the other transcription factor binding sites that you haven't loaded in yet might have a lot more probes.
Yeah.
Yeah.
Cool. Do you guys understand like the idea?
Yep.
Okay. If you have any questions, like let me know, but I would just rewatch the video, A, B, try it on your own. And what I always do when I code is I have Sublime text right next to me so I can follow what I do. The only reason why I can like do this in a command line is because I've been doing it for a long time, and I've done it so much that I can remember my steps. But if you don't remember your steps and what you call your variable names, you'll get lost.
You get lost.
Yeah.
Repetition is key.
Cool. All right.
Thank you very much.
You got it.
Thank you, Ethan.
Yeah, I don't think I can. Okay.
Yeah, I'll stop sharing.
Okay. Good night, guys.
All right, good night.
Peace.
See ya.